Hey guys, and welcome back. We are up to the last new lesson of the year. This is our last material that is brand new. Everything else we do will be some kind of review or some kind of preparation for next year. I will tell you a little bit more about that by the end of this week. But for right now, we're going to go over how to write the equation of a tangent line. So our last official date here is going to be May 12th. That's 2020. And of course, the first little section here is a do now. So if you want to shut this off and try it first and then come back and check, do that. So here goes. The slope of a line called AB is -3. Normally that would have a little line above it. What is the slope of a line that is perpendicular to AB? So that question's a little review there. You have to remember that perpendicular lines have negative reciprocal slopes. So if this slope is -3, I have to make it positive, and I would make that 1/3. So it's positive 1/3. Now, next question says, think about what it looks like when a tangent to a circle meets a radius drawn to the point that the tangent hits. What is true about the tangent and the radius? So you may remember this from a couple of units back. If you have a circle and you have a tangent drawn to that circle and that tangent meets a radius, every single time you have that situation, you have created a right angle where they meet. How? Because they're perpendicular. So what's true about the tangent line and the radius? They are perpendicular to one another. And so we're going to use what we know about perpendicular lines to help us write the equation of a tangent line to a circle. There are two different ways you can write the equation of a line. This is your third review question here. Write the general form of each. So slope y-intercept form is the one you've known forever. That's y equals mx plus b. You probably remember from earlier this year, from back in middle school. M is your slope and b is your y-intercept when you're in that form. Now the other way we learned to write the equation of a line we did this year, and that was the point slope form, and that is y minus y1 is equal to the slope times x minus x1. And you just have to remember with that you would be plugging in the slope here for m again, of course, and the x1 and the y1, you'd be plugging in the coordinates from any one point on the line. So you can use either of these when you write the equation of a line. You will probably find that using point slope form is actually a little bit easier, even though I know that equation is not as comfortable for some of you. So we're going to practice with that today. So first new example here, they want us to consider a circle with this equation, and they want us to find the equation of a tangent line drawn to this circle that passes through the point 1, 1. So they're telling us that it has to pass through a particular point, and they're telling us it has to be tangent to that circle. So it turns out that there's a couple of steps that we can follow anytime they ask for the equation of a tangent line, and that's what we're going to walk through here. First thing you want to do is find the center of the circle. So the center of the circle, remember, is what you get if you just switch up these signs here. So the center of this circle would be the point 3, 5. Radius, of course, is what you get if you take the square root of that number that's over here on this side of the equation. So radius is the square root of 20. Oh, I'm sorry. I don't really need to find the radius, so that's good review. What I do need to find for step 2 is I need to find the slope of the radius. So how am I going to find the slope of the radius? Well, I have the center, which I just figured out to be the point 3, 5. And I have a point, and that's the point 1, 1. So what I can do is I can find the slope of the line that connects the center to the given point. So I'm going to use the point 3, 5, and I'm going to use the point 1, 1 that they gave me, and I'm going to find the slope. So remember, slope is change in y, so y2 minus y1 over change in x, so x2 minus x1. So I would have 5 minus 1 here over 3 minus 1, which would be 4 over 2. Oh, that's nice. That reduces to the number 2. Now, the next step here, so step 1 was I had to find the center. Step 2 is I had to find the slope of the radius. Step 3 is to find the slope of the tangent line. Well, we know that the radius and the tangent have to be perpendicular to each other. So the perpendicular slope, which will be the slope for the tangent, will be the negative reciprocal of 2. And the negative reciprocal of 2 would then be negative 1/2. So you find the center, you find the slope of the radius using that center and the given point. You find the perpendicular slope because that's what you're going to need for the equation of the tangent. And then we want to write the equation of that tangent. That tangent is the line that has this new perpendicular slope and passes through this point that they gave me, 1, 1. So if I have a point and I have a slope, the easiest way to actually write the equation of the tangent line would be to use the point slope formula. Y minus y1 equals slope times x minus x1. And that means I have y minus 1 is equal to negative 1/2 times x minus 1. Now, if they don't give you any more specific directions than that, you're finished. You plug that information in and you're done. Now, if it's a multiple choice question and it's not in this format, then you might want to use distributive property and then add a 1 to both sides so you can get the other form. But if they don't tell us differently, we can just do it like that and we can say we're done. We wrote the equation of the line that passes through the given point and has the slope that you found in step 3, that perpendicular slope. That's it. And now we're going to practice that with a couple more problems. That's really the whole lesson for today. So we have one more example here on the back. And again here, I must have forgotten to change this when I typed it. I happen to give you the same number that this circle equation is equal to. It doesn't matter though, because remember, we don't really need that. What do we need? First thing we need is the center of the circle. So the center of the circle is going to be what I get when I switch these signs. So that is the point 4, 5. Step 2, I'm going to find the slope. And the slope, of course, is going to be y2 minus y1 over x2 minus x1. Where does the 2 and the 1 come from? Well, the center is 1 point, and they gave me the other point. So I have to use 4, 5, and 0, 7. So let's say I decide to go like this and make this my first, make this y2. So 7 minus 5. And if I go in that order, then I have to go 0 minus 4. That means I have negative 2 over that's positive 2 over negative 4. And that reduces to negative 1/2. So that's my current slope here. And then I need the perpendicular slope. So the perpendicular slope is what I'm going to get if I take the negative, so that'll become positive reciprocal, so positive 2. And then I'm supposed to write the equation of that tangent line. Well, the equation of the tangent line is going to be y minus y1, which is 7, equals the slope times x minus the x value. Now, what that means here is, I'll write that equation again. That was y minus y1 is equal to slope times x minus x1. Oops, I went off the page again. I'm sorry. There you go. So y minus y1 is equal to slope times x minus x1. For this part of the problem, the y1 and the x1 that you use have to be the point that they gave you back up in the problem. So we're using the point 0, 7 that was given to us in the problem right there at the top there. So all I have to do to finish this up is neaten it a little bit. I wouldn't leave x minus 0. I can make this y minus 7 is equal to 2x. And then just for the heck of it on this one, why not just add the 7 to both sides and we can get to y equals mx plus b form, y equals 2x plus 7. And that's it. That is how you write the equation of a tangent line. What's really important for you to know out of that, of course, are the steps. If you know the steps, then you're able to perform those couple of quick little operations. So I hope that's not too bad. You have some homework to practice that. and then I'll see you back here tomorrow for our review sheet for this unit. Have a great day. Bye.